We'd like to thank the following sponsors for helping provide this video.
Is the President and CEO of Assembla, managing software development across 15 countries. And he's also the author of a new book about to be published called Unblock, and we'll be raffling off a couple of copies at the end. And one other important thing to know about Andy, if you might have seen the name recently in the newspapers, for any of you who are involved in contract software development, Andy led the charge to convince the state legislature that was not the wisest piece of legislation they ever passed, and was rather instrumental in getting that overturned. So we appreciate it, Andy.
Thanks, David. That was hot in September. What's hot now is continuous delivery. Okay, this is a survey from my friends at Perforce, which shows that, well, what I didn't put on here is 80% of all SaaS companies say that they're doing continuous delivery. And I believe that if you're in the SaaS or online business and you're not doing continuous delivery, you're probably not going to survive. The benefits are pretty substantial there, but 51% of companies sort of broadly surveyed, and Perforce deals with sort of online software companies, have at least some projects that they say are moving to continuous delivery. And you can see sort of some of the reasons why they think they like it. Faster time to market. These are tiny little, I'll read them. Better quality of product, competitive advantage, higher customer satisfaction, and reduced cost of development. So I have my own list. Why would you want to be more continuous? If you run an online service, you have to be, because your competitors are going to be faster than you if you don't. A good example of this was what happened with Microsoft with Office 365. Eventually, Steve Ballmer had to get on the squawk box and say, we have to release more frequently. So that's one of the phrases that I use, because they were going up against Google Docs. I'm going to tell a story about what happened to us, and it's pretty common with people. When your product becomes more complicated, your release times get longer. It takes longer to test it, and that's essentially a signal that you need to switch to these continuous methods. You need to be testing continuously instead of batching it up and not getting through it. If you're using the MVP techniques where you're constantly iterating and testing with customers, obviously you need to release very frequently. And but the surprise winner here is if you have a really big project, okay? That's known to be the most expensive problem in technology, and we're going to show how some of these continuous techniques can solve that problem. I'm going to whip through a lot of material here and stop at every section, probably every 10 or 15 minutes, and take some questions. So I hope you guys appreciate that. The idea is there's really a lot of material, and there should be something in here that you can take back and use. It's kind of the concept. So on scaling, we're going to get to what top tech companies do when they scale to big agile projects. This is sort of the Scrum and Safe method, adding more hierarchy, holding big meetings, putting everyone onto the same cadence every 2 weeks, and then coordinating these big releases every 10 weeks. So all of these things sound like a pain in the butt, and we're going to figure out how to get around them. They're really, in my opinion, more obstacles than solutions. So I ran into the idea of Kanban from Damon Poole at Eliason. Awesome idea. And I was using a process that I call Scrumban, which is Scrum, but you skip the iteration planning meeting, because I have distributed teams. I have 35 people in 12 countries at this point, and they don't get together very well for planning meetings. And that was working pretty well to a certain point, but then the release time started getting longer. It started taking longer to test. When we did releases, there was a lot of stress. So stress is going to be one of the major other indicators. If you have stresses around your release, that's a signal that you need these techniques. And actually, competitors were doing better than us. So we made a study of this process, which is why at this point I have a book. Some of you have been unlucky enough to have read the review edition, and most people said the same thing, which is, wow, this is great material, but it needs to be turned into a story. So hopefully this will be a little more of a story. We talked to a lot of people who are pretty good at this, and we started working on it. So this is a graph of release frequency. How many releases did we do per month? We were supposed to do 2, but you can see that we sort of fell off here. That's the sign of the pain. And that's when I said, look, we need to go start using these continuous techniques, start testing and releasing, if possible, every day. And what's great about this is you can see it's an incremental process. This is lean management in action. You release more frequently, you get better at it, you improve your testing, your deployment, your planning, and pretty soon it starts to go up. At this point, releasing about 250 times a month, or about 10 times on a typical day. So every change can go straight through to release. And that did solve the problem. It's a lot less stressful. It also produced an unexpected result, which I will share with you, because the first thing that people think about when they think about releasing more faster is lower quality. And what we found is we actually used the flexibility we got from being able to release whenever we wanted to hold things longer in a sort of a beta test state and release more slowly with higher quality. So that's the kind of flexibility that we're going to look for out of these continuous methods. I'm going to start with what I call continuous Agile, which is really the adaptation that we make with task management and project management to move to continuous. And then I'm going to go on to the stuff that people associated with classic continuous delivery, which is really managing your code so that you can test and release it continuously. I sort of, made a little waterfall diagram here, but this is often what happens inside a Scrum sprint. It can be pretty waterfall-y. I see that a lot. And what we really want to do is we want to use some very specific techniques to get rid of any stages in here that are waterfall stages. So for instance, you could skip planning. There's a lot of stuff that you can just skip. We'll see that later. And that's a pretty big improvement in productivity. You can automate deployment. Guys go up and make stuff, right? You should be able to push a button for that, so that gets rid of that task. You could blend it in. So testing is something you're doing all the time. You're not waiting towards the second half of a sprint to do testing. And then what I call lagging, probably a better word for it, but the idea is that you're constantly pulling tasks, you're building stuff, you're releasing, but you're not launching. Maybe you're not doing all your localization, documentation, marketing, whatever. You can do that on a different schedule. So we've unblocked, right? We're going to release, 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 and then launch. So that's the idea behind lagging some stuff.
I'm losing my voice, so I apologize if you can't hear me.
So you said you skipped the planning. Would you just incorporate that into the development cycle, or would you, because there's supposed to be some degree of planning, right?
Well, obviously planning is important. My feeling is it's so important that you should just be doing it all the time rather than doing sprint planning meetings. I find those very painful. So skip the event and do the work in a more efficient way. So how does that work? Well, this is my little diagram of a bunch of tasks that have been sorted and groomed. And you pull tasks off the top, you do your sprint planning, and you also, if you sort of do classic Scrum, you spend a fair amount of effort estimating, which I'm famous for saying that that's a complete waste of time. And then hopefully you can finish those tasks. So that's sort of the classic Scrum view of a sprint. If you have a distributed team or something, you probably do it differently. You might skip the sprint planning meeting, do the grooming, and just ask your developers to pull one task when they're ready. Just use the lean pull method to get your work. And this is sort of a pure gain, in my opinion, because you skip some of the work, and you can still batch it up when you release it. Wait 2 weeks, or wait a week and a half, feature freeze it, make sure all that stuff is ready to go, and release in a batch. But while you're doing that, while you're doing this, you're running your test system, and your test system is at some level of quality. So you're actually continuously delivering some sort of testing or test system. And if that gets to a high enough level of quality, you can just release it. So the move from sprint planning to sort of a pure Kanban, where you're releasing one piece of work, is actually very small when you look at it this way. So that's the Kanban view, which is the view we're going to espouse for our continuous Agile. But you have a problem, right? Because you're releasing stuff, you never actually did a full test of it. Why do we do the batches? Because we know that when we make a release 1.065, release 1.065 is a coherent tested batch of software. That's why we do the batches. And so the problem is, how do we test this stuff? That was the first question I asked Damon when he tried to get me to do this. And the answer is not magic, but test layering. So actually, John pointed out, it's really obvious when you look at it this way. Every change that you make to your code goes through a series of tests, and it's sort of winnowing out problems, and by the time it gets to the end, it should be bug-free. So you start with unit tests that the developer runs, and then you might run some automated tests on your continuous integration. You guys, if you do this, how many people do these that do it this way? How many people here? All right, nobody admits to it. It's a pretty common way to do it. And then you might do code review, right? The machine thinks it works, but your programmer needs to make sure that it's good. And then you might say, hey, is it usable? Let's throw it over to a QA guy and have them look at it. And then you might actually release it, but only show it to beta customers. So there's switching that goes on. And then finally you release it, and if there's a bug in your release software, you should get notified somehow. And in fact, this is pretty easy to get to this stack because you just start the other way. You might, I'm writing a prototype, I release it. Oh, I found a problem in my release code. So that's the first layer of testing. And then you work backwards closer to the source of the error, adding more tests. So that's actually what people do. And if you start to really get hyper about it, like Edmunds, the guys that bring you the car reviews and stuff, they have 9 layers of testing that their code weaves its way through. Similar things like unit tests, really easy things like static code planning, static code scanning, you just put a script in there, you don't have to do anything else. So there's 9 layers of testing here. But what's great about it is, screw the code coverage, okay? These are sparse layers. You don't want to have to fill in code coverage on everything. That's a very painful thing that people do. In continuous delivery, you just don't do it. What you do is much more lean. If you see a problem, you have tests, you can figure out where's a test, where can I put a test that's going to find that problem. So it's nice to have a lot of layers because you have a lot of choices about where to put a test and make it more effective. So that's the payback is, you're just putting tests in that are going to help you.
Question?
Yeah.
Concern? I'm concerned about user experience issues. I mean, you get that on your layering top issue. You had some favorite beta customers that you showed to first. This Edmunds doesn't have that even at all. And sometimes user experiences, or you build something that isn't quite right until somebody sees it done. And it might get out too soon. That's one of the values of chunking.
Not getting out too soon. We're going to cover that in the next slide.
Oh.
Okay, so John noticed the other day that Constant Contact was giving him a new UI for Agile New England, which is in some sort of nonprofit bin, but was giving Assembler, which is in the for-profit bin, the different old UI. So it's pretty obvious what's happening here is that somebody at Constant Contact put a switch in to show the new UI to certain customers and test it. So that's what's happening. And you see this all over the place. I had a friend who worked for a bank, and he said, well, when I stick my ATM card in, I actually get a different ATM UI than the real customers. I'm getting the beta version. And people who make cars, we have some customers that do that, they actually get different software, different engine tuning when they get in their car. So it's a pretty common technique. And what people are doing here to solve your problem is they're separating release from launch. So the developers are just releasing, that's the unblock. But its stuff is switched off. It's not actually unveiled or revealed to all users until the marketers, the product managers want it to be. So we're going to relieve a lot of stress by letting the development team run full speed, and then we're going to unveil later. So there's sort of a typical pattern for this. There's one code base. If you can read down here, it says one code version, no special test build, no long-running branches. These are all things that drive you crazy, right? Is anybody who's just been driven crazy by merging a long-running branch? Yeah. Or maintaining like the beta version of the server? So if you do continuous delivery, you would really go nuts with all the different single, one-piece flows that you have if you had to do that for everything. So you just dump everything into one code base, pretty much what everybody does, and you switch it on and off. First it's in test mode, and then it goes to sort of QA mode where people can see it internally, and then you start turning it on for beta customers. And then you do the unveil. Show it to everybody. That's the launch, right? But by then, what's great about this is it's been released and deployed, and you know it works. It's been through the release and deploy process so many times that this is almost a non-event. It is a non-event from a development point of view. So there's a complexity, which is that if you're building a whole big new UI or something, you actually have both implementations in your code at the same time. It makes it more complicated. But the payback is even bigger, which is that when you unveil it and then you can throw away the other version, it always works. And so using these techniques, you can sort of, we usually think about software as moving up the quality curve and sort of getting slower as you go, right? Alpha, beta, release, maintenance mode, right, which is way up here. But actually what you're going to be doing if you adopt these continuous methods is you're going to be moving back and forth. If you need more quality, you're going to add more test layers, and you're going to hold stuff longer. And if you need to get it out fast, you're doing like MVP stuff, you're going to remove layers and hold it for a shorter time so that customers see it in more of a raw state.
So it sounded a few slides ago as though you start with no tests or very few tests, and you add tests as you see problems. Do you want me to repeat that?
I get it. Well, that's always going to be true, right, if you start from nothing. If you apply this to your existing software, you're going to have a whole testing mechanism that you're already running. So we're not asking you to back up. But what we are asking you to do is once you get all this working, to realize that you have choices. Did that answer your question?
Sort of. It's fine for now.
But the net result is a lot of people who adopt these processes do what we do, which is they choose to increase quality and actually hold things longer. And on average, the reason that sort of increased quality was one of those big bars in the first survey was because the duration of a bug is so much shorter, right? If there's a bug out there annoying people, you're going to fix it, and on average, you just have fewer bugs out there. So now we're going to get into the stuff that's sort of the classic continuous delivery. I said I would take questions, yes.
What about dependencies? I mean, you have backlog items, some are dependent on each other. If you have continuous release like this, do you have to link together certain backlog items so you don't release them without each other?
Yeah, so one guy's releasing something and he needs something from somebody else, you have to coordinate that. So the trick is going to be, I'm going to get to that later, the trick is going to be, that's hard to do. That's really hard to do. Make sure that everything is lined up so that all the pieces of something big happen. So you're going to do two things. First of all, you're going to smooth it over a little bit with this switching so that people can put stuff in advance, but it's not used until the next guy comes along. And the other thing you're going to do is just a lot of peer-to-peer communication. You're going to try to put in machinery, and I'll talk about that so that people find each other as they're building the different pieces of this. You can't take away the fact that it's hard and people have to think about it, but you can give them a good way to talk about it and do that planning.
I'm concerned, you've got to be carrying a certain amount of legacy code around in your system as you do this continuous delivery.
I got crap loads of legacy code.
Right. How do you get it out? You need to have a project that's going to remove it at some point along the line, and that's not ever going to be something somebody wants to do.
Oh, you're saying that when stuff gets switched out?
Yeah.
Actually, I find that people do like to do stuff like that. It's hard to deal with users and stuff. It's easy to make your code better, and there's a lot of engineers that like that. But you're right, it's work, and somebody has to go back and do it. It's not easy, our business. So, do you have any suggestions for that?
I don't.
I haven't found that to be a problem. That actually found that people are pretty enthusiastic about stripping out the code that's been switched off, because it gets in your way. You do see it.
I just wanted to make a comment on that. Legacy code in itself isn't necessarily the problem. Untested code is the problem. So if you've got code and you've still got tests in there for it, yeah, I mean, it's adding some load and everything, but if the code's not changing, things aren't, and it's not even getting run, it's not inherently a problem itself. If it gets turned on, but there's already unit tests testing it out, integration tests that are testing the various configurations. So one of the things that I did at my job that I just ended 3 weeks ago is I started a project called Multiple Client Configuration Project, where instead of saying, oh, we have our standard test data and our fake client, and we ran through everything using the same exact data, well, we've got clients with 5 different variables, setting up different test environments for each one and running through all or a sampling of those combinations and permutations to cover that problem.
Yeah, and that is a really difficult problem. If you have like software that has multiple versions of the client, multiple versions of the server that are being released, a lot of people who do this have the luxury of running a SaaS system with only one version. So that makes your permutation thing a lot easier. And if you're running this, you sort of have an incentive to drive customers into the most current version. You see that with browsers. You know, they used to offer multiple versions, and now they just automatically update. They have a strong incentive to drive you into one version to minimize their testing. So you can control your environment at some level, right, if you use these techniques. Any other questions?
I think I heard you say that people are checking into one branch.
I'm going to get to that.
Okay.
There's different ideas on that. I'm going to get to that in the next slide. Okay, go. So I could talk for hours on like code contribution. I've cut it back a little at John's suggestion. But what we're essentially going to do is we're going to move from task and team management, which is a lot of what Agile people like to talk about. There's people, many of them. And we're going to talk about managing code. Code, how do we get the code, how do we build, test, and deploy the code. That's the core of, this is the core of Agile, and this is the core of continuous delivery. And what's so great about this is, with all the new software that's out there for cloud computing and open source development, and there's just so many new techniques for continuously build, testing, deploying. That's where the innovation is. This is where the new energy is coming from, and in fact, if you think about it, what's happening here is productivity is going to the people that use the most computers. It's sort of like having the biggest coal mining machine. It's the way I like to think about it. If you can use more computers in your work, you increase your productivity, the productivity of each human. So that's what's happening, is a lot of this is being automated, and that's where the productivity is coming from. So that's an important point. Does that sort of sink in about Agile and how we're getting sucked in this direction of managing code, automation? So this is the idea: manage code if possible, not people. This has sort of been refined by the open source guys. They don't even try to manage their people. They just accept code contribution. People are hate to be managed, but they're happy to contribute. So we're going to cover some different code contribution patterns. I've identified 4 of them in the book. I think we have just 2 of them in this slideshow. And if you want, you can go to the website, continuousagile.com, and get more details. But there's a little bit of controversy here. So Well, I'll just start with this. This is the simplest pattern. It's the one with no branching. So Jez Humble wrote a book on continuous delivery and said you should never use branches. You should always use this pattern. I think of it as the early as possible pattern. So what you're trying to do is stick all of your code changes together in one place and test them together as early as possible. Constantly running automated tests. If there's a problem between them, you're going to find that as quickly as possible, and if your team is fast, you're going to fix it. The thing is going to tell you there was a problem, and it's going to be, the build's going to be red if there's a problem, and then it's going to be green if there's not. If it's green, you have a release candidate. It's a very simple system, and that's great because sometimes the test systems are really complicated, so you need a simple topology to manage them. The problem is, so this is, here's a picture of how it works, a simple picture of how it works at Edmunds. It actually goes through more than one release candidate phase and gets those different tests. Remember we talked about the test layering. But it's essentially centralized continuous delivery. You commit here, and it goes through the various tests. But it turns out that Jez Humble was completely wrong about the branching, because there's lots of people that need branching in their development process. The great news about this is that you find a problem if two changes conflict, then you find the problem right away. But the bad news is you can't release it. You can't release either of those changes. What if you're assembling and you're releasing 10 times a day? You want to release change A even if it conflicts with change B. That's the situation that I'm in. So what we do is we hold each change out on its own branch as long as possible. We run tests. We use a bazillion servers. John made me take out the slide that showed like 80 servers, each running their own test version. But each of these runs on its own server and has automated testing. And when we're after we've tested, we're sure we want to release it. We do this switcheroo. We merge the current version of the code. We deploy it, and then we drop it in as the current version of the code. So we're constantly doing this little switcheroo where we're putting in one change at a time. It's a different thing. It's just, it's not true that you shouldn't use branches.
If you're running off one branch, why do you ever have a conflict as opposed to the developer merging things up and reconciling it themselves before they commit?
Well, if your developers were always never made a mistake, then
okay.
It'll always be good. But that's why you have test layering. Like developer is one layer, and then there's other layers. Here's some other layers of testing. You might find a problem in one of those other layers that was actually a conflict between two commits that were made into the same code branch. So there's reasons to have branches. Another reason to have a branch is Garrett-style development, where you're testing and reviewing on the branch before you merge to the main line. We do. I actually have a picture of that later on. So various reasons to use branches. Don't believe what they say about not using branches. But if you are using branches, don't make them long running. They shouldn't last more than a day or two at the most. You're going to use feature switches to keep your features separated, because if you let them run long enough, then they just become a pain in the ass to merge. This is usually the hottest topic when I do like workshops. What are the roles in a continuous process? I'm just going to contrast this to sort of more traditional development that might be an iterative Scrum-based process with a QA group. In the continuous process, the QA people do not decide when to release, the developer decides when to release. Developer literally, I've never seen an exception to this rule. In a truly continuous process, the developer has to push a button to release his code. And there's a reason for that, because you have more power and you also have more responsibility. And this forces developers to think a lot more about things like automated testing. They go out for beers, they push the button, they go out for beers. If it doesn't work, that person has to come back. That's not a discipline you can apply to a QA person. They can't come back and fix it. But so you're forcing a lot of responsibility onto these developers. And a lot of people, when I point this out to them, they say, Yeah, you're right. You know, my developers are kind of lazy. They throw code over to QA. They really should be giving me code that's bug-free, and they don't. You know, they throw code over, assuming it might have bugs. How many of you guys agree that that happens? Yeah. And there is this theory that bugs are optional, that if you use enough code review kinds of XP processes, you aren't going to end up throwing bugs over. But basically, they're just pushing stuff out there. They have a huge amount of power. The countervailing power is that you can hide these features. You have those feature switches, so your product managers and marketers and guys get to turn stuff on when they feel like it, but they don't get to hold it back from release. Massive power to the developer. So what do the QA guys do? Well, the QA guys, they have a little less work because the developers are making better code, but they have to act as consultants. If you're a developer and you want to know whether you should release something, you're going to call your QA person and say, I really need you to come over and test this and cover my ass. It's literally what happens. And so it's a consulting role. And hopefully they'll have more time to investigate usability, which is really where the battle's being fought right now, not quality. And you can also get them involved in your lean process improvement, actually measuring productivity and quality and that sort of thing. Another really big change is with product managers or product owners. So these guys are, which is me, right? It's one of my jobs, dealing with three really big changes. The most obvious is you're going from batch to continuous. And the first thing that a lot of people notice is it's a fire hose. The developers actually get speeded up and they're spitting more stuff out. It's harder to keep up with them and make sure all the stuff they're doing is good. They have a tendency to get ahead of you and then release stuff that's not very well thought through from a product standpoint. Another thing that's happening is going from requirements, it used to be we would deliver requirements, to delivering a great user experience. It's pretty obvious that some products can succeed even if they don't deliver all the requirements, if they're cool products. And many pieces of enterprise software deliver all the requirements and are crappy products that nobody uses. So there's really very little link between requirements and success, but a huge link with user experience. And if you want a user experience, you have to measure the user experience. You have to actually watch and see whether users like your product. And so what we're doing is we're moving from sort of guesswork, strategy, and forecasting to actually trying stuff and measuring it. It's a pretty big difference in product management. And that's actually the big unexploited aspect of this whole thing is every time when I talk to software companies, they don't use the data they have. They don't collect data. They throw away data that they have. They know they're not using all of this usage data. And what's so painful about that is that it turns out that users use less than half of all the stuff that you do. The guy at Microsoft who was responsible for actually measuring usage with Office 365 said that when we started measuring usage, it turned out that a very large percentage, he used the word very large percentage, of our ideas were bad. And it doesn't mean that they're bad, but they're just useless. If you could figure out the 50% of stuff that your users are ignoring, and you could ignore it, you would double your productivity with the same team. Either that or you could just take half the week off. You know, it's like pretty amazing. So how do you do this? We went from product owner to what we call story owner. So the idea is a product owner can sort of stick requirements in and hope for the best. But we're actually going to do a lot more work, and we're going to make a much better feature. We're going to work with the developers iteratively and look at this stuff as it comes along. Then when we release it, we're going to switch it on for different kinds of people, and we're going to user test it or A/B test it or do something like that. We're going to see how people respond to it. We're going to hold it until it's great. Then we're going to release it. Then we're going to measure whether anybody, we're going to communicate about it, the big unveil. Then we're going to measure whether anybody uses it. And so through this process, I think you can see it's a lot more work, but you get a much better feature. And that's the trade-off, story owner, product management.
Question?
Yeah.
So in this case, because people may have different ideas of the size of a story, can you give an example of what a story might be?
Sure. To me, I don't think it's important how big the story is. You should pretty much do this for any feature. So I'm producing a new product called Big Plans. It's a lean planning product, and we just recently added real-time messaging to it, so you can sort of do messaging files chat next to the task that you're talking about. And we've instrumented that so that we can see if anybody uses it. We've also beta tested that, and so we've done all these things. It actually turns out to be a long project because you release it and then you go back and you keep circling it until you like it. It doesn't just go once through the thing, but it might last a month or so to do something like that, so a month of work.
Okay.
It's more work, and I found when I started doing this, I just didn't have the capacity. I still don't. So if anybody's great at this, just call me. But what you can do is you can grab out somebody who understands the user story and make them be a story owner. We wrote a story owner like cheat sheet guide. We make, we sort of grab people from other functions to do this because it's such a big demand for it.
Yeah, I was wondering, looking at the last several slides of the various roles, I kind of saw a parallel, like we're talking about continuous releases in the code base, but discrete launches or visibility, through unblocking. And it seems there's a parallel to what I envision as a continuous integration of a code base with a periodic release, just sort of different terminology, but still under continuous integration, things are continually put in the code, and under periodic releases, they get made known to the users every once in a while. So there seems to be a parallel between what you're talking about and what I envision as continuous integration with periodic releases. Are they parallel, or are there some fundamental differences?
No, they're very similar. So at the end of this slideshow, I show a slide on what I call the continuous delivery dial. So it's the idea that if you want to relieve stress in your development group, just let everybody release continuously. But you can still, inside the development group, but somewhere in that release process, you can still drop it as a batch for testing or certification or whatever it is that you want it, packaging, burning into ROM, whatever it is that you want to do. So I think there is a pretty substantial parallel there.
You had mentioned earlier that the QA role becomes more of a consultant. And so do the developers, are they doing acceptance test-driven development? Is that automated? So are they really testing against the acceptance criteria before they make a decision to release?
No, because they're going to release stuff before it even meets the acceptance criteria. But it's their job to get it there with whatever testing mechanism that they have. You don't want to hold back, right? You want to get as close as you can to the acceptance criteria. There was one other guy. Okay. All right, I'm going to keep going. So,
One last, sorry. When is a story done?
I just lie down and cry when people start talking about the definition of done. I think that's the stupidest thing I've ever heard, because it's done when it's unveiled. It's like very clear. If it's unveiled, it's done. You might have to do it again, but it's done.
But you're still measuring it when it's unveiled.
Yes.
So when do you stop evaluating the story? But you can't, right? You can't evaluate everything all the time.
I mean, there is a clear definition of done. You unveiled here. It's done. It's still your responsibility to make your product better. I don't know that there's any that's why we have product managers that have to think, is it good enough? How important is this? You're going to be doing measurement and trying to figure out whether it's really there. I mean, what do you think?
I think that if I have 1,000 stories that I've released over 2 years, there's no way that I can continue to evaluate that and take on new work. And
Well,
so
exactly.
my
I mean,
workload
you do at some point just say, hey, that's good enough, and move on. And actually, people do that pretty quickly.
Okay.
But if it's not good enough, you have to make tough decisions. Sometimes you have to give up on it.
Isn't that what you're,
A question on the release, that you, when you say release continuously, I think you used it in two contexts. One is release for the actual users to use, and also release to stage somewhere so that you can do further testing, correct?
Yep, I'm using that in a couple of different
Repeat
ways.
the question.
The question is, what do I mean by release? Do I mean it actually went to users, or do I mean that it's ready for sort of final stage of testing? And it's very flexible. Fit it to your own needs. It would be my answer. If you have a SaaS or an online service, everything should be released all the way through, but that's not the way a lot of products work. So, go as far as you can. That was the idea of the continuous delivery dial with these frequent releases. It's still going to help you. But there is a whole question of vocabulary too, which I cut out, which is continuous integration, right? We're testing everything, running automated tests on everything all the time. And then continuous delivery, which is sort of, it's releasable, but I might only release it opportunistically. Continuous release, which is sort of what we do at Assembla. If it works, you're releasing it, get it out of here. And then continuous agile, which is sort of all this stuff bundled up with things like this continuous product management.
don't you add continuous voice of the customer before you jump back to planning, right? Because you want to understand the maturity of that release or that feature and not do an Office 365. So isn't your voice of the customer feedback loop continuous as well?
Yeah, I mean, I'm sort of lumping a lot of stuff in with measurement, and you're going to have to figure out what it means to measure. I think voice of the customer is just asking people what they think is that's sort of the fallback. If you can actually get data on what they do rather than what they say, you're in even better shape. And a lot of times you can build that in. But these are all that's the opportunity, right? So now we're going to get up to the new stuff, which is matrix of services or MAXOS. Trying to attack this problem that's really the most expensive problem in tech, as I've described it. Capers-Jones said that if you have a product that's over 100,000 function points, it's probably not ever going to get finished. That was his observation. That was about 10 or 15 years ago that he made that observation. It was true at the time. We have a lot of companies now that are just smashing through that barrier. The no silver bullet, mythical man month. We're just crushing these barriers right now, and I'm gonna show you guys how. It's with these continuous techniques. So the first, sort of the core of it all is the Services Megatrend. So in the beginning we had desktop software, right? Or that actually came after the beginning for me. And then we had web apps. I built a lot of these. You make an app, and it's one app, and it has one database, and you can see it in the browser. But actually, that app was a couple of services. They had a database server under it. It was actually a couple different servers. And what's happening now is we're busting that up into lots of different services. And they run in the cloud, and they run on all different services. And some of them are headless. They just talk to each other. Your app talks to your database. Some of them talk to your mobile phone, or your watch, or your car. It's Internet of Things is all based on this. Some of them suck in data. That's big data. So all of the big trends in IT right now are based around this idea of these services that float around. And Google's been dealing with this for over a decade because they have such a big, complicated system and they have so many servers. So you have to imagine that even just doing a search on Google involves thousands of servers that are doing lots of different things and feeding that, sucking the information in and feeding it together. The way that they think about these services is it's not 1,000 different products. They actually think of it as one system. So they have 15,000 developers running 5,000 projects with one code base. That's the way they think of it. Any piece of code. If I'm a developer, I can change any piece of code in Google, and it'll be tested and will fit together with all the other pieces. And even at this scale, they can go from idea to release in 48 hours at sort of a best case. And the way they did it is they divided that, chopped it up into these thousands of services. Each service is maintained by a very small team, 3 to 4 people, usually co-located. It's not the way I do it. And then they take the work of all these teams and they feed it into this centralized continuous integration system that runs automated tests and makes sure that everything works with everything else. There's a twist here that's important, which is they test it with the most recent development version of all the other services. They don't test it with the production version that's going to be released.
Places, if they're allowing duplication of services, are they also allowing duplication of data?
I don't know. But think about the situation that I described where you're going to unveil, let's say, a new search algorithm. Well, it's almost certain that you have duplication of data because you're showing users the old indexed data, right? But you're at the same time you're building and also running the searches, dark searches on the new data. So you have it in at least two places in order to be able to make the switch over smoothly.
For that period of time.
Yes.
But I'm talking about after, assume that we've cut over to whatever is new.
I don't have a theoretical answer to your question, but I can say that in modern cloud systems, data is replicated a lot. It goes in layers, right? It gets backed up and fail over, and the assumption has to be that data is cheap.
Okay.
I can talk a little bit to the duplication of data. There's a lot of the stuff in this microservice architecture where duplication of data is perfectly accepted. Normalization slows things down and inhibits scaling, so do relational joins and so on. Get a lot of NoSQL stuff. What's important is that eventually the important data gets reconciled.
Okay.
But it's okay for certain elements of data to be inconsistent to a certain extent and to be separated from one another long enough to support this kind of massive scaling.
Yeah, in less technical terms, if you're going to scale, if you're going to show the Facebook news feed to 1 million people, you're going to make copies of the data. That's how you're going to do it. So we've switched over from normalization and trying to keep one copy of the data to making a bazillion copies so that we can spew it out across the globe. That's a pretty big change. So anyway, so before developers release a change, they test it with the most recent version of all the other developers' stuff. They don't test it with the production system they're about to release into. It turns out to be, that was the clever twist that got me thinking about this. So here's what's actually happening. You've divided your software into services, and each service has a team that maintains it, usually a small team, single functional, just programmers that pull in the skills they need from other parts of the organization. They review and test their change on a branch. Then they stick it in the main line, and they deploy that to the test system. And the test system is testing with all the other teams. It's one test system. And if it works here, then it gets promoted. They pick that up and they throw it over into production. So that's the idea. And if you have enough of these service teams, they just release whenever the hell they feel like it. You get hundreds or thousands of releases per day out of this process. So the implications of this are kind of interesting. So for me, the most interesting implication is you've replaced your management with a machine. Okay, this is a fiendishly clever innovation from Google. So it's really hard to design a project plan, with the Gantt chart and the dependencies and where all the arrows go. And that's sort of what makes it hard to manage these projects. But it's pretty easy to make a continuous integration service that if two services are dependent on each other and one guy changes one, it notices that, throws an error, and it sends email to both teams. Okay, so you've sort of replaced your scrums and a lot of your dependency planning with a continuous integration system that's even not very complicated. And you'll see more and more of this as time goes on, management being done by machine. So you have producers and consumers, and they have to make sure their stuff works together. If there's a conflict, instead of having a big meeting, you've linked those guys up, they talk directly, so it's peer-to-peer communication. And it seems almost too simple to work, but it does. So there was somebody who was asking about dependencies, so this is one of the clever ways to handle dependencies. Another interesting aspect of this is that you ever get frustrated because you want to do new stuff with your programmers, but more than half their time is spent on maintenance and improvement of the stuff they've already done? It's literally always more than half their time. Well, if you think about it in this system where the service teams are actually getting feedback directly from the production system, from their services, from the running servers, and they're seeing errors, they're seeing slowdowns, they're maybe even getting user support issues. They're getting requests from other people that are consumers of their service. All that stuff can go straight to the service team. It never has to go into the backlog planning or any kind of management planning process. So you have half as much planning to do because at least half of it is just being done inside the team. And not only that, it's a lot faster, right? If there's a bug, it doesn't go through any kind of a process. It just goes to the guy that fixes the bug. So it's a pretty substantial gain there from self-managing and monitoring.
I was wondering, you were talking about doing the testing and getting, doing the testing on this continuous releases, and if there's an error, the two teams work it out and so on. Though it's kind of a moving target if you have continuous release, because then when the first team makes its correction and goes to test again, it's on a different system than when they originally tested. So something else may have creeped in that renders the fix useless, because essentially you're testing on a moving target. So how do you work that? You may run into race conditions because every time you solve one problem, you then implement it and it's a different release.
Well, these services tend to be backwards compatible, so people aren't going to pull services that other consumers are using. And in practical, it sounds like that could happen, but in practical operation of this system, that's not what happens. People notice that, and they deal with that. It's not an easy job, but they figure out how to. They're very adaptable. If you put them into this environment, they will figure out how to make sure they don't break it. And that's sort of generally true of continuous delivery. So once you put people into it, the engineers get really smart about not breaking stuff.
And notice you only have one train for releases, basically your integration environment, that's where everybody goes through that. Thank you. I'm struggling there. You only have one train for releases, which is your integration environment. Do you have a separate QA environment, or the QA just does it within the integration environment?
No, just one. Most of the people that do this, it's just one. You can start to see why they do it this way. Like, I don't do it this way, but my system isn't that complicated. If you have thousands of services, you can't stand up too many variations. Does that make sense?
Absolutely.
So self-managing, and then there's a scaling advantage. So if you want to you want more development capacity and a bigger system, you just add services and add service teams. And you can do that because the service teams are responsible for managing the production services. Normally, as your system gets more complicated, your ops guys who monitor the servers and keeps them running, that becomes the bottleneck. It's impossible for them to keep track of more than 10 or 15 different things. We're talking thousands. So you blast past that barrier, and what happens is your ops guys become DevOps guys. They build tools that help the service team see what's going on with the servers, and then the alerts and problems with the servers go straight to the programmers who understand that service, and not to the op guys who just have never heard of it because it's one of 1,000. It's a pretty important innovation there. And another important innovation is, I hate the definition of done, and I hate this, we're going to get a team together and we're going to let them congeal, and it's going to be a multifunctional team. We're going to go through this huge organizational effort to pull guys out from the various functional units in the company and make this great team, and then we're going to preserve that thing for years. It's just so undynamic and it's so complicated. What the guys do that do this, it's programmers. Remember, programmers decide when to release, they have a lot of power. They build these teams, it could be around one programmer, a tech lead, and you could support some services. So there's not a lot of complexity in the role that they're filling here. The multifunctional aspect of that team comes from pulling in, that's sort of at the programmer's direction, the skills that they need. So these are things that make this really pretty scalable. And a great example of this that's not Google Bright is HubSpot. They have 60 or 100 developers, so it's mid-scale. But they've done a fantastic job of this. They took their monolithic app and they busted it up into 200 different services. And you know, it's sort of a machine there. They have the 3-person programming teams, which you can think about as the smallest team where somebody can take a vacation. They've really stripped this thing down. And they have 20 of those, and so each team is responsible for about 10 services. They actually take on a pretty big responsibility. Not only that, for each of those services, they're responsible for design, programming, testing, release, monitoring, and responding to production alerts. So these guys, it may be a single function team sort of from one point of view, but they're covering a lot of bases. There's no full-time QA, and their product managers and user experience guys are shared. They get pulled in as needed. So what makes this work is they have a lot of tooling to do things like continuous integration. It knows where the teams are. You know, I can see where my servers are and where stuff is deployed, and I have dashboards that see into those. So they do a lot of tooling to help these teams monitor their services. It's a great example. Now I've talked also to Constant Contact, our host here. What happened is this is actually a pretty big competitive advantage, and HubSpot started to go after Constant Contact's turf. You know, once they got this in place, Constant Contact hasn't been quite as aggressive about pursuing either the service architecture or this tooling. And you know, that's something that they're working on now. So this is a pretty big competitive issue. Now I'm going to talk about sort of the enterprise problem. So one of the solutions that I keep seeing around here to managing large projects in an enterprise is Scaled Agile Framework. This is they were here a couple months ago, and they presented this chart. And basically what this is you start with Scrum teams and Scrum iterations, and then you build on top of that program management. So you make sure everybody's marching in the same direction. You sort of give them, every 2 weeks and 10 weeks, you give them their marching orders, and they get together and they figure out their dependencies. So it's sort of a logical way to start with a Scrum team and then add the stuff you need, the hierarchical management stuff, to make it a coherent program. Makes a lot of sense. The way Dean Leffingwell described it to me is, I'm an integrator for ideas. You know, I'm sort of pulling together all the ideas that companies use that do this. Problem is, you would never do this if you were Google, okay? You would just never do this. You would never have big meetings every 2 weeks or 10 weeks and try to get everybody in a room. And you would never wait, you know, 10 weeks to plan a release. You just would never do it. You know, all these things look like, these are the things that SAFe does that are such a pain in the ass. And so, you know, slow it down. Multifunctional teams, you know, they're hard to build. So what you would do is you would automate it. Try to get rid of this work. Automate the management with your continuous integration system. Make you know, use the programmers, the hackers that you have to lead your teams. Try to get them communicating peer-to-peer as quickly as possible, but on an as-needed basis rather than on schedule. You're going to unblock so they can release without going through, you know, someone else's process, and you're gonna get those releases out there frequently, and then you're going to later come along and sweep those up into product launches. You know, the stuff we see on the web, we basically get the new features before anybody launches them, markets them to us. And yes, so that's what they do. It's almost exactly the opposite. So something to think about. And here's another something to think about. So I've talked to both sides of this equation. Leading retailer, a local retailer of office equipment. They have a monolithic online ordering app. It's a big Java app. It's pretty awesome. You can order anything you want for the office. They're good at it. They use Kanban, lean management, but it's a monolithic app. So they release it, and then their ops guys hold it for 3 weeks because they want to make sure that it doesn't crash. They're bringing in millions of dollars a day. They want to make sure it's reliable. It's such a big app. It takes a long time to test. So it's 9 weeks, beginning to end on this cycle. Let's compare that to their largest competitor, Amazon. Amazon has, I don't know how many thousand teams, few thousand. They're one of the originators of this service-oriented MAXOS process. And so they said 2 years ago, they're probably faster now, they release something somewhere once every 11.6 seconds. At any given time, they're updating more than 10,000 servers with new code. So in the time that retailer X takes to do one new release, Amazon has done 300,000 changes. You know, and if you've ever been exposed to this sort of thing, it's just a chainsaw that just grinds you up. There's just no way to compete with that, no matter how good you are with the old style Agile. And I deal with various people that compete with Amazon. Some of the hosting companies that compete with Amazon are my customers. And my favorite quote was, "It's an emergency." That's what they said about their development process compared to Amazon. I think we're a little ahead of schedule. You think I should go on to the, do you guys want to just talk about this, or do you want me to do another 5 or 6 minutes? Okay, so how can we, so this is pretty important, how can we simplify adoption? I'm going to give you a couple ways to think about it. One is, we talked, a lot of people don't have SaaS, like they don't just release to their internet server. They actually have to go through some sort of release or packaging or compliance process. So if you have that situation, you want to run continuous delivery as far as you can. You want to relieve stress, you want to have that innovation and continuous testing and everything else, and then drop it into the release train and release it, okay? Just, it's very practical, you know, run it as far as you can and then run the batch process. And over time, you can move this style for closer and closer to the point of final release. So that's one practical way to think about it. Another way to think about it is that a lot of companies have what I call core IT. It's got annual budgets, it's secure, it has to be reliable because thousands of people need it to do their work. But those companies are also doing fast IT projects. These are the continuous delivery projects. Marketing websites, mobile, stuff that you've thrown out in the public cloud, things you're doing with your partners. And we can use this service concept, the Services Megatrend, right? Slap an API on top of this thing. What a great source of capabilities. And you know, go to town. Everything's not the same, right? These are different things, and that relieves the stress through that API layer. You asked me, you know, how do you get to this point with automated testing, for instance? So if you do these 4 things, your developers it'll work. It's really that simple. You have to do mandatory code reviews so that you have a place to ask developers for tests. You have to make them take responsibility for pushing the button to release, so then they do a better job putting in these test layers. You have to release more frequently so that there's a consequence to breaking the build. And this is a little harder, right? It's not quite the same level of motivation, but if you ask the product managers to do the unveil and the measurement, if you ask them to not only throw the requirements in at the beginning, but also to do these 2 things at the end, they'll tend to fill in the blanks, sort of like the developers, and just do a better job all the way along the line. So this is sort of, you know, my original take on it, having seen it a couple times. But really, it's as simple as the lean process. Release more frequently, just keep releasing more frequently, and improve that cycle. It does work. It's not, you don't have to make it into a huge deal. Just have to be good. So there you go. Yeah, that's all.
Some projects I used to work on involve multiple companies and multiple organizations. How do you see this working in a multiple organization coordination where the various businesses have their own incentives, their own structures?
Well, to me, that's a case where you might want to consider this, see if you can take advantage of the idea of managing code, not people. So each of those participants is a contributor in some way to the project. And what you want to do is, you can't really control what they contribute, but you can put in sort of an established process for reviewing that, testing it, sending it back, or including it. And you know, that might relieve a lot of stress. That's the way I look at it whenever I deal with partners. You also might want to think about it, if you think of this MAXOS process as lots of services working together, and there's a continuous integration system, well, there might be multiple companies making those services. So for instance, a great example of that kind of ecosystem, of MAXOS ecosystem, is Facebook. they have all these plug-in apps that sort of appear inside the Facebook system. And they are actually running continuous integration to make sure all those apps work. So that's some ideas, right? Managing code, not people.
How would you describe, how would you describe an organization where this could be done? That is, what attributes would you say are requirements of an organization in order to be able to apply this?
Obviously, you have to have the ability to release more frequently to someone. So if your customers aren't willing to look at anything more than once a year, you're going to run into some obstacles. So that's the first thing. And the second thing is, it needs to be a developer, programmer-friendly organization. We've talked about how programmers really drive this process, and they have to have some engagement and power and influence in the company, I believe. So if you have those two things, I think you can do great with this process. A lot of people say, oh, my engineers will never do this. They're set in their ways or whatever. But I had a guy tell that to me, and then I went back to see him the next week, and he said, one of my best engineers who would never do this moved to Facebook, and on Facebook they made him write and release a change on the first day. That was the thing, and the boss of this company goes, I couldn't believe it, he did it that one day. So it's not the people, it really is the incentives. Did that make sense?
Yeah, I guess I've worked in an environment where it was developer-centric and where users were willing to look at things, but I still don't think this would fit in because we were getting code from a vendor and integrating our own changes to the vendor's code, and then had to verify that that didn't break stuff for our users. And I don't see how we could have.
Well, it's not going to work in 100% of cases, but what we're trying to do is identify places where you will get a benefit from it. And one of the benefits is developers love to do this. More than any other kind of Agile, right? 51% of the people said they were doing it on that chart. It's not true. They love to say they're doing it, right? They love the idea. That's what's so great about it. They're not all caught up with it yet, as much as they say. But nothing's going to work in 100% of the cases. It's got to be practical.
Do you do retrospectives with the teams, or do they do it themselves?
Yeah, you really should do retrospectives. This is a continuous improvement process. You should do retrospectives. I like to call it happiness survey, regularly scheduled happiness survey. Right? Well, that was Sutherland's idea, and it's been working for me. It'll usually surface real issues with the team, and that you can fix. So what you want to do is surface issues like death and taxes. You don't want that kind of issue. You want stuff you can fix. It does work. So yes, retrospective.
I hope you haven't already answered this. Does it make the production environment more reliable or less reliable? Can you comment on that?
Yes, I mean the answer is it could go both ways, depending on whether you want to sort of jam your stuff out there and make it less reliable. Most people find, the reason I told the assembler story where our system became a lot more reliable is because that's the way most people use it. So they're gonna take advantage of the fact that they can fix bugs a lot faster to make sure that there's just fewer bugs on the production system at any given time. They're also going to take advantage of this feature switching to hold stuff that might potentially be buggy for long enough for it not to be buggy. And they're going to use the feature switching thing to make sure that they don't get bugs when they switch over to new features. Those features are sort of bug-free at the point of switching. So that's the way most people try to use it.
One question, one of the later slides talks about development teams doing all the design, programming, test, releases, and so on. What struck me is that they do the design. Now, if you have a lot of teams, 20, 50, 100, and each of them is doing design of a piece of it, is there a danger of focusing on trees and missing on forests? Because you have so many teams looking at a specific point and kind of missing what the forest is supposed to be?
Yeah, there's absolutely. I mean, these teams tend to get ahead of themselves and release stuff that isn't that well coordinated. That's a common symptom. When I say it's developer-led and the developers do the design, they do bring in UX and product management experts to help them on the design. They make a lot of the decisions. They sort of pull the threads together. But they are drawing on centralized resource, if you will, a centralized expertise that can help add some of that coherence. But there's a trade-off here, and if you get enough of these teams running, they are going to produce stuff that you have to go back and rework to make it more coherent. I'm happy with that trade-off because actually, if they're moving that fast, it's faster just to do it twice, right? You have them get the prototype out there and then loop back and go back and fix it so that it looks like everything else. It's actually faster to do that than to do the design once through. But again, it's all practical. It's all what works for you. Yeah, over in the corner.
Did you guys start with a rigid framework? Like, where would you say you began? Demonstrate summary level. How long did it take you to get to the
Well, I showed the graph. Yeah.
Repeat the question.
The question is, I think he's asking about Assembla's development process and whether we started with a specific rigid Agile process. And is that the story? Is that what you're asking? No, I've never been a fan of sort of at least the Scrum, the planned Scrum sprints. Partly because I work in distributed teams. We always did the Scrum bond where we were just pulling one task at a time, and then we would do feature freezes in batch releases. So that was the level of organization that we had. We always had a fair amount of automation in our system. We're engineers and we build development tools, so a lot of automation, code review, and that kind of thing going in. So that was a big advantage. Kids nowadays have that because they work in these open source projects where that's the way people do it. So it's a pretty common skill right now. And we've made a lot of changes. I mean, we go back and forth in how much planning we do, whether we have feature teams or not, or just story owners that pull things together. So, and that's pretty typical. People tend to move around in how they organize these things. With these continuous methods are not prescriptive the way Scrum is. And I have to say, you're getting it from me. I don't feel good about Scrum. I feel like there's a lot more ways to do software development, organized software development. What we're really doing is trying to open you up to some options, around the basic lean principles.
So you're saying the tools can
So issues can float from production back to engineers, right?
What do you mean by issues?
Well, there's a bug, right? So it doesn't get in the backlog. Engineers just get email that they just fix it.
There's a certain class of bugs which are on the production server in production that get cut off. Yeah, that's an important speed enhancer.
And in your experience, what's the percentage of the time that engineers spend on those issues?
I think in any software development process, whatever the process is, people are going to spend about half their time on optimizing and fixing stuff that's already released, and about half their time on new stuff. I can't, I don't have any statistics on that, but I've been doing this for 30 years, and that's how it's always been for me. I mean, what do you think?
Well, I usually budget 40% for things that I don't know of, and 60% for the new work.
So if you budget half, you're going to be in good shape.
Well, we're 10% apart.
Yeah. Okay.
Yes, time for one more question.
Yeah, I was just curious about testing. Do developers write automated tests? By that, do you mostly unit tests, or do you do other kind of like automated testing?
No, when I say automated testing, I think about the whole layer. Sometimes it's unit tests, which are scripts you can run on your own computer to test units, right? Objects. Sometimes it's regression tests. I don't go big for regression tests because I like to change my software faster, and the regression tests don't keep up. But we could go back and look at that stack of different kinds of tests, input, output tests. Did I get the right data in or out? The point is to be flexible, to not try to get great test coverage on unit tests, to try to get great test coverage on the problems you actually have in all of those different layers of testing. That would be my recommendation. So the answer is no, it's not just unit tests. But the easiest place to get tests actually is unit tests with this technique, because when you ask a guy for tests during a code review process, most likely you're going to ask him for unit tests. So that tends to be where you get the best coverage. All right, time to move on.